Bridge in China could send your heart racing because it's the world's highest, and it opened today. It stands more than 1,800 feet above the valley below.
China's bridge-building achievements have amazed the world, transforming from basic structures in the 1980s to engineering marvels that now rival and surpass global standards. These mega bridges don't just symbolize advanced technology, they showcase the brilliance, determination, and innovative spirit of Chinese engineers. With record-breaking spans and groundbreaking designs, China's bridges have left American engineers in awe. How did China go from following to leading the field? In today's video, we'll explore the incredible construction technology behind these jaw-dropping projects that are reshaping the future of infrastructure. Number 9. Hong Kong-Zhuhai-Macau Bridge. The Hong Kong-Zhuhai-Macau Bridge, as its name suggests, connects Hong Kong, Zhuhai, and Macau, stretching over the Ling-Ding-Yang waters. Spanning an impressive 55 kilometers, it holds the title of the longest sea-crossing bridge in the world. But this bridge is more than just a huge structure. It's a mix of a bridge, islands, and tunnels. To safely navigate busy shipping lanes, engineers built a remarkable 6.7 kilometers long underwater tunnel. Each part of the tunnel weighs an enormous 80,000 tons, about the same as the weight of a large aircraft carrier. Building an underwater tunnel is an extraordinary challenge. For example, when joining each part, the alignment tolerance can't exceed 2 centimeters, a nearly impossible feat when working in deep waters where strong currents, silt, and intense pressure make precision difficult. Yet Chinese engineers, with their advanced skills and determination, made the impossible possible, successfully completing this amazing underwater tunnel. This really shocked American engineers. There are 4 main ways to build underwater tunnels: the drill and blast method, the tunnel boring machine, TBM method, the shield tunneling method, and the immersed tube method. The drill and blast method uses explosives to carve out sections of rock, which are then cleared and the tunnel is lined. This method works best for stable geological conditions. But when water seeps in due to cracks in the rock, engineers inject grout to create a waterproof barrier. China's first underwater tunnel, the Xiamen Tunnel, was built using this method. The TBM and shield tunneling methods use large, specialized machines that drill through hard rock or soft soil. These machines not only dig but also put together concrete segments to support the tunnel, preventing collapse. Shield tunneling in particular is highly efficient and flexible because it's fully mechanized, making it ideal for many types of soil. The Hong Kong-Zhuhai-Macau Bridges Tunnel was built using the immersed tube method, which involves lowering prefabricated tunnel parts onto the seabed and carefully connecting them. This process requires careful waterproofing of the parts to make sure they stay sealed and safe. Building an immersed tunnel is a detailed process, like creating a finely crafted masterpiece. The first step is building a dry dock, a large watertight basin where the tunnel parts are made. Engineers dig a large rectangular area near the tunnel site, making sure it is level and watertight using advanced techniques like slope excavation and diaphragm walls. This dry dock serves as the base for building the tunnel parts. Once the base is ready, steel reinforcement cages are placed inside molds, and concrete is poured to make the tunnel's walls. After curing, engineers keep the concrete in the best conditions using mist cooling and blankets to keep moisture. The parts are then equipped with important systems like ballast water systems, pipelines, and monitoring devices. The outside is coated with a waterproof layer of polyurethane, and the ends are fitted with steel bulkheads, waterproof seals, and sealed doors to protect them during installation. Once the parts are fully equipped, the dry dock is flooded, and the parts undergo strict testing to make sure they are ready for transport. The next step is the careful digging of a trench in the seabed. Large dredgers handle the rough digging, while smaller, more precise dredgers perform fine leveling. The bed's flatness must be accurate to within 4 centimeters to ensure the parts can be placed with perfect accuracy. Now comes the most exciting part, transporting and installing the parts. Tugboats and anchor cables position each part in its right place, while digital monitoring systems guide engineers to ensure perfect alignment during the installation process. To install the parts, they are flooded and carefully lowered into the trench. Once in place, the parts are connected and strengthened with gravel, backfill materials, geotextiles, and anti-scour stone cages to guarantee long-term stability. The final touches include adding electrical systems, fire prevention measures, and decorative finishes, as well as laying high-quality roadways to make sure the tunnel meets transportation and safety standards. From the dry dock construction to the precise alignment of each part, every step in building the immersed tunnel shows the utmost engineering precision. Shockingly, there's another fascinating bridge in China that holds that a great record, and that is number 8, the Beipanjiang Bridge. The Beipanjiang Bridge is an incredible feat of engineering. Stretching 1,314.4 meters in length, it forms part of the Hangrui Expressway. This bridge connects Dugay Town in Yunnan with Laolong Village in Guizhou, crossing over the dramatic Nizhu River Grand Canyon, which is why it's also known as the Nizhu River Bridge. When the Beipanjiang Bridge was completed, it marked the opening of the entire 3,404-kilometer-long Hangrui Expressway. What truly sets it apart is its breathtaking height. The bridge stands a massive 565 meters above the river below, which is about as high as a 200-story skyscraper. It is currently the tallest bridge in the world. If someone were to fall from the bridge, they would plummet for over 10 seconds before hitting the ground. A truly terrifying thought. In 2018, the Beipanjiang Bridge earned a Guinness World Record for being the highest bridge globally. But despite its fame and recognition, China didn't build this bridge to win awards. It was constructed to make travel easier for locals. The distance between Dugstown and Puli Township isn't very far, but due to the mountainous terrain and lack of a direct road, it used to take a grueling 4-hour journey. Travelers had to cross 3 mountain ridges and navigate 40 kilometers of winding mountain roads. Now, at the Beipanjiang Bridge, this once-long journey has been reduced to just a minute or two. This not only makes travel faster and more convenient, but it also promotes the region's economic growth by improving access and encouraging trade between the two areas. The Beipanjiang Bridge is located in a stunning area within the Yungi Plateau, known for its unique karst landscape. This landscape was shaped over time by water slowly dissolving and depositing rock, both underground and on the surface. However, the mountains here are fragile, making it hard to build bridges. After spending a year surveying and exploring the area, Chinese engineers decided that building the bridge 565 meters above the ground was the safest option, ensuring they would avoid the many caves and cracks in the rock beneath. When engineers in the United States heard about the plans for the Beipanjiang Bridge, they skeptically predicted that it would take China 3,000 years to finish it. But against all odds, construction began in 2013, and the bridge was ready for use by the end of 2016, only 4 years later. The Beipanjiang Bridge is held up by 2 giant concrete towers, with the tallest one standing at a towering 269 meters. The bridge deck, made of steel, weighs an incredible 20,000 tons and is as long as 5 Titanic ships lined up end to end. In fact, the bridge deck is so enormous that One World Trade Center in New York could easily fit underneath it. The deck is suspended from the towers by 400 kilometers of cables, which, if laid end to end, would stretch from London to Amsterdam. Spanning an impressive 1.3 kilometers across the ravine, the Beipanjiang Bridge's towers reach 750 meters above the valley floor, higher than the combined height of 2 Eiffel Towers and the Statue of Liberty. Building the bridge wasn't easy. Engineers faced major obstacles, starting with the difficult terrain of the Beipanjiang Canyon, which has steep slopes and complex geology, making construction a real challenge. Additionally, the weather in this southwestern region was a constant threat. Engineers had to deal with harsh winds, thick fog, heavy rainfall, freezing temperatures, and frequent geological hazards. These extreme conditions made it even harder to build a bridge that could stand strong and secure in such a demanding environment. The main question facing the engineers was, what type of bridge could stretch across the mighty Beipanjiang Canyon, which spans an incredible 670 meters? Traditional designs like beam bridges, arch bridges, or concrete cable-stayed bridges were out of the question. They simply couldn't cover the massive gap. The team had to choose between steel truss bridges, cable-stayed bridges, and steel truss girder suspension bridges. But there was a big challenge. The canyon's cliffs were made of fragile karst rock, which wasn't strong enough to handle the immense weight of a suspension bridge. After careful consideration, the designers decided on a cable-stayed bridge. It was the best option to balance cost, environmental impact, and safety. The Beipanjiang Bridge was planned as a double-tower cable-stayed bridge with an impressive span of 720 meters. But drafting the blueprint was just the beginning. The real test was building it. The U-shaped Nizhu River Canyon, over 500 meters deep, posed a huge problem. Transporting massive bridge sections, each weighing hundreds of tons, to such a remote and rugged location seemed impossible. To overcome this, engineers came up with a clever solution. They broke the giant sections into smaller pieces, each weighing about 10 tons, and used special techniques like reassembling and cantilever launching to piece the bridge together high above the canyon. But the challenges didn't stop there. To support the weight of the entire bridge, 224 steel cables were used, each just 15.2 millimeters in diameter, but incredibly strong. These cables were made of galvanized steel with a tensile strength of up to 1770 megapascals, enough to endure the enormous forces at play. Since the bridge would face extreme weather, engineers took extra steps to protect the cables from corrosion. They applied multiple layers of galvanization and high-density polyethylene (HDPE) coating inside and out, ensuring the cables would last for decades. Finally, after years of effort and innovation, the Beipanjiang Bridge was completed on September 10, 2016. Today it stands as a marvel of engineering, connecting people across a canyon that once seemed insurmountable. This next bridge is outstanding and even more impressive. Let's find out. Number 7, the Longjiang Bridge. The Longjiang Suspension Bridge in Yunnan, China, is a truly remarkable structure that connects the cities of Baoshan and Tengchong. Standing at an astonishing 300 meters above the ground, it's as tall as a 100-story skyscraper. To give you a clearer picture, imagine looking straight down from that height. It's like standing at the top of a giant building. But what makes this bridge even more impressive is its location in an area known for frequent, powerful earthquakes. This makes building a bridge here an incredibly challenging and risky task. To make sure it's safe, engineers use the latest earthquake-resistant technology and specially designed materials. Still, just thinking about being on a bridge that high up, swaying as the ground shakes beneath you, is enough to make anyone's heart race. But don't worry, this is just the start of our journey to even taller and more daring bridges. Number 6, the Sidu River Bridge. The Sidu River Bridge, which crosses the Sidu River, connects the Enshituja and Miao Autonomous Prefecture in Hubei Province with Fengji County in Chongqing City. This bridge is crucial in linking the central and western regions of China. At over 2.5 kilometers long, it soars to an astonishing height of 560 meters, higher than the Empire State Building. Building this bridge wasn't easy. It had to be built in a remote, hard-to-reach area, nestled between two huge mountains, stretching across a deep, narrow valley. To get the first cable across, engineers had to use rockets. After 3 years of intense work and incredible innovation, the bridge was completed. Driving across the Sidu River Bridge offers breathtaking views of the valley below, making it an exhilarating experience. Now we move to an engineering marvel, the second highest bridge in the world. Number 5, the Jinshajiang Bridge. The Jinshajiang Bridge, an engineering marvel, stretches across the mighty Jinshajiang River in Yunnan, China. Its main tower rises an astonishing 228 meters high, while the vertical height of the bridge itself soars to 479 meters. From the bridge deck to the valley floor below, the distance is 335 meters, earning it the title of the second highest bridge in the world, right behind the Beipan River Bridge. What makes this bridge even more impressive is that it holds the record as the world's largest cable-stayed bridge, spanning a deep mountain gorge. The entire structure is 1,386 meters long and is made up of 128 massive steel truss segments. To grasp their size, consider that each segment weighs a staggering 175 tons. That's as heavy as more than 100 family cars combined. Adding to the bridge's remarkable design are its two main cables. These cables are built from 42,000 high-strength galvanized steel wires with a combined length of an unbelievable 87,000 kilometers. If stretched out, these wires could wrap around our planet twice. Number 4, the Liuzhijiang Bridge. The Liuzhijiang Bridge in China is not just a marvel of engineering, but also a breathtaking sight to behold. Spanning a remote canyon in central Yunnan province, this suspension bridge is the longest and arguably the most stunning single-tower design ever constructed. The distance from its towering structure to the anchoring mountain is an impressive 780 meters, breaking the previous record held by the Jinshajiang Hutiao-Oxia Expressway Bridge, which had a span of 766 meters. Crafted with a sleek steel box deck, similar to the renowned Longjiang and Pulley bridges of Yunnan, the Liuzhijiang Bridge is the crown jewel of the Yuxi to Chuxiong Expressway. Its design and scale make it the largest and tallest structure along this route, embodying the pinnacle of modern bridge engineering. While suspension bridges with single towers, or even none at all, have been built in the past, none compare in size or grandeur to the Liuzhijiang and Jinshajiang Hudioxia bridges. Among earlier examples is the Dazi Bridge in Tibet, built in 1983 over the Lhasa River. Spanning 415 meters, with a total length of 500 meters, it features an anchorage perched high on a cliff, supported by cable stays. Though impressive for its time, it pales in comparison to the modern achievements in single-tower bridge design. Efforts to innovate in this field have faced challenges. For instance, in Hubei province, a bold idea was proposed for the Zhejiang Bridge, envisioning a nearly towerless design to span a 300-meter deep gorge. This plan included stubby towers just 20 meters tall and a central span of 540 meters. Though ambitious, such designs often face technical hurdles. Next, we will visit the cable-stayed steel box girder bridge in Hunan, and that will be number 3, the Aizhai Bridge. The Aizhai Bridge, an awe-inspiring cable-stayed steel box girder bridge, spans high above the Aizhai River in Hunan, China. Completed in 2016, this engineering marvel stretches an impressive 1,176 meters, with a staggering height of 336 meters from the bridge deck to the valley floor, earning its place as the 9th highest bridge in the world. Only the Beipanjiang Bridge, Jinshajiang Bridge, and Beiling River Bridge stand taller. The bridge's main span, long and sleek like a dragon, seems to slice through the clouds like a mighty sword. At times it appears as a rainbow bridge, linking the breathtaking landscapes on either side of the valley. Its 2 main towers, each soaring 206 meters into the sky, stand like vigilant guardians, their presence even more mesmerizing when illuminated at night. What sets the Aizhai Bridge apart is its unparalleled design and scale. The cables and towering height make it a global record holder. From the 200-meter-high observation deck, visitors can marvel at the stunning scenery while reflecting on how human ingenuity and the natural environment can coexist so beautifully. Next, let's take a look at the Guozigu Bridge in Xinjiang. Number 2, the Guozigu Bridge. The Guozigu Bridge in Xinjiang is a marvel of modern engineering and a true game-changer for the region. As Xinjiang's first cable-stayed bridge and its highest, it holds immense significance. Not only is it the largest and most essential bridge in Xinjiang, but it's also China's first road bridge using steel truss cable-stayed technology, a groundbreaking achievement in infrastructure. This incredible structure stretches about 700 meters across a deep valley, with its deck soaring roughly 200 meters above the valley floor. Built with state-of-the-art steel truss technology, the bridge required 17,000 tons of specialized steel and high-strength bolts, replacing traditional welding for greater durability. The precision during its construction was mind-blowing, with every part needing to align within 2 millimeters. Such an engineering feat didn't come cheap. It cost around $3.4 million per meter to build, bringing the total cost to a staggering $2.39 billion. The construction of the Guozigu Bridge pushed the boundaries of innovation. Engineers used cutting-edge methods like controlling the temperature of large concrete volumes, towers, beam asynchronous construction, hydraulic jacking systems, and self-moving templates. Number 1, Yingwuzhou Yangtze River Bridge. The Yangtze River Bridge is a triple-pylon suspension bridge with 4 sections, 200 meters, 2 850-meter spans, and another 200 meters. It holds the record as the world's longest steel-concrete composite suspension bridge. The steel-concrete composite girder adds stability by making the bridge more resistant to gravitational forces and minimizing the sliding of cables over the central pylon. It also solves common problems with road surfaces seen in traditional steel deck bridges. The main pylon has an H-shaped frame, while the central pylon is built in an inverted Y shape using both steel and concrete. The lower part is made of reinforced concrete, and the upper part uses a steel structure arranged in a herringbone pattern. This design ensures stability by balancing the movement of the pylons and preventing cable slippage. To secure the bridge cables, gravity anchor blocks are used on both ends. The north anchor is built with an open caisson foundation, while the south anchor has an expanded foundation supported by a reinforced underground wall. The caisson foundation uses a honeycomb-shaped design, which allows it to be precisely sunk into the ground, even in a crowded urban area. A new eco-friendly construction method, involving hydraulic pipes for debris removal, helped reduce environmental impacts and made it easier to build the caisson foundations in the busy city. What are your thoughts on China's fascinating capabilities in bridge construction? Share your thoughts with us in the comments section. Don't forget to like and subscribe.